Space wants you.
We're going back to the moon and then to Mars.
Want to go to space? Let's go.
Just getting to space is the easiest part.
Draw it, write it, build it, dream it, innovate it, invent
Because
it.
once you get to space, you actually have to live in it. Space wants you dead.
Let's expand our thinking.
It's time to think outside of the box.
Let's go.
I see stars.
Hello and welcome everyone to the Cities in Space podcast, episode 4. We are here to help you discover your future in space. I'm so happy to have you join us today. I'm your host, Holly Malier. Today, we are taking a tour of humanity's future lunar and Martian habitats. And here to illuminate us is our guest, Melodie Yashar. Melodie is VP of Building Design and Performance at Icon Build, which is a construction technologies company focused on large-scale additives. We've got your 3D printing, your robotics, your manufacturing for Earth, and you guessed it, audience, space. Melodie has had an amazing career as a space architect, designer, and educator. I can't wait to hear about her work today. Melodie, I am so glad to have you here today. Welcome.
Thank you, Holly. It's a pleasure to be here, and thank you for inviting me.
Yeah, well, I'm happy. How the heck are you?
I'm doing great. Thank you.
Well, Melodie, last time I saw you was at the National Space Society's International Space Development Conference. You were keynote speaker there. And before that, you were keynote speaker at our Cities in Space competition. I got to say, during both talks, I feel like my jaw was dropped because I felt like, wow, the future is here. It's like right now, listening to what you are doing with Icon. So in addition to being VP of Building Design and Performance at Icon, you also teach graduate and undergraduate studies in design. Prior to working at Icon, you were a senior research associate with Human Systems Integration Division at NASA Ames, co-founder of Space Exploration Architecture, and you won awards in 2015 for your Mars Ice House and for your Mars X House in 2018. Over the past decade, you've published hundreds, maybe thousands of white papers, but you have published a lot of papers on ideas ranging from like architecture, 3D printed habitats, human-centered design, and crew situational awareness in spaceflight. And now, drumroll please, you are a collaborator with Icon for Project Olympus.
That's right.
Oh my gosh, I cannot wait to talk about this, as well as talking about Mars X House and Mars Dune Alpha at the Johnson Space Center at JSC. But before we dig into all that, do you ever sleep? Do you sleep? I mean, just reading that, I'm tired. I feel like I could go take a nap right now. That's a lot.
It's a labor of love. I love what I do, and when you work with joy, it never feels burdensome.
That's a really good point. When you're stepping into your passion, it doesn't feel as much like work. But let's be honest, it's still a lot of work, what you've been doing.
It's still a lot of work. Yeah. Sometimes I'll tell you what, it would have been easier to focus on either terrestrial Earth construction or in-space construction. Doing both is a challenge. It is a challenge, but it's the way that I've been able to support one and bring learnings from one domain to the other, which is, I think, the best way of doing it and realizing these concepts faster and more efficiently.
Yeah. It's a reciprocating, mutual, benefiting relationship, I would say,
Yeah.
right? Did you
Yeah.
always I mean, did you always dream of wanting to be a space architect? Like, was this your path?
It's such a good question. I have always been enamored by the idea of living and working in space, but I never really understood early in my career that this was a viable career trajectory or a career path. Certainly,
Mm,
you never go online and see job postings for space architects, at least
right?
in the past when I was in school, you certainly didn't. But now, with this new commercial landscape of private companies who are building space habitats in low Earth orbit and beyond, like that is slowly beginning to change. And so I think I was part of a new wave and a new generation
Mhm.
of designers and terrestrial architects who were looking to bridge our terrestrial architecture background with something that was more technology driven. And the fact that I was able to sort of bridge my love of design with my love of space, it happened quite naturally. It was something that evolved over time. And the more projects that came to me and that I collaborated on, the more viable this became as a career. Suddenly, we started receiving phone calls from private aerospace companies, and it became more and more clear to us like, no, actually, this is a capability and a gap, frankly, in most systems engineering's workflows that we can provide a lot of value for. That's how my journey as a space architect really began. It started as a passion project where we were putting projects together over on nights and weekends after school, after my graduate career was done, and evolved into something much more.
That's so cool to me. I know a lot of students listening are really fascinated with this. And in previous podcasts, we've talked about jobs and careers because part of our mission is to help students see that they have so many options for career. I love that you talk about the relationship to design, technology, and space. But, there's so many opportunities. And I
Mhm.
think before we know it, we're going to be seeing a lot more job postings that, for me 20 years ago, I would have been like, what? That's science fiction. And now that's real, right?
That's right. So friends of mine who I went to graduate school with and who know within the industry, the space architecture community globally are working as space architects in Axiom in Sierra Nevada, at Lockheed. So there's definitely a viable future for those of you who are interested in space architecture. And I definitely encourage you to take a look at the Space Architecture Technical Subcommittee. Those people in these groups are the ones who are creating the future of space architecture, and they're always looking for collaborators, thought partners, and others who can help them promote that vision and make this a reality.
Yeah, that's great. Oh, say so. With that said, let's talk about Project Olympus. I'm
Yeah.
so excited about this project, and I know you've been doing work with lunar landing pads and the lantern. I know you're going to talk about habitats. So tell us some of the stuff that's happening with Project Olympus, that collaboration in particular, and what you're planning for that, if you would.
Yeah, yeah, absolutely. So, in the early days of Project Olympus, when it first started, essentially, I was working with an applied research group referred to as Space Exploration Architecture. I met the CEO of ICON, Jason Ballard, through our mutual customer at NASA Marshall Space Flight Center. And essentially, he posed the question. Uh, Assuming we're going to be deploying 3D printing technologies on the surface of the moon this decade, what will be the most needed infrastructural elements for us to print? Like, in order to design the technology and determine hardware requirements for these 3D printers on the moon, what are the use cases and applications for that technology? And so he brought myself and my teammates aboard to investigate, like, what will this technology print and what will the first habitats on the moon be that this technology realizes, and what are the other infrastructure elements needed to sustain a permanent presence on the moon? So over the course of about a year and a half, icon brought on partners such as my group to investigate and do an architectural investigation as to what landing pads, roadways, habitats, unpressurized garages might look like on the surface of the moon.
Wow.
And, we were collaborating with structural engineers and we were collaborating with consultants in the field, but we didn't quite know how impactful our architectural work was going to be. And effectively, what happened is that after these initial investigations, when they were shared with NASA, and in particular, our client at Marshall Space Flight Center, they were able to use that imagery and attach to those concepts and basically say, this is exactly our vision for lunar excavation, construction, and surface development holistically. So they adopted our concepts, particularly for the landing pads, the outfitting, and used that imagery as part of STMD's general roadmap for lunar construction. That also gave way to ICON's SBIR Phase 3 award, which was a $60 million contract to actually develop the technology and deploy it on the moon this decade. So it's essentially all contributing to the vision of how this technology can actually serve the needs of multiple stakeholders on the surface of the moon. And the architectural investigations were absolutely critical for how this all played out, and the work that we're currently doing on Project Olympus to realize this technology, test it, and have it deploy on the moon aboard Eclipse lander. That's our current trajectory. Is that we're doing small scale testing right now using regolith simulants within our lab in Austin. We've developed a large robotic.
Wait,
Oh,
wait,
go ahead.
wait. Let me interrupt you. But okay, first of all, I've got to say, like, 9-year-old Holly is like jumping up and down, screaming, "Wee!" Because this is so exciting. But can you explain what regolith is and additive technology for the 3D printing, just so our audience has a good understanding of that, just for a minute?
Yeah, absolutely. Great question. So, the premise for this technology is that we want to use the local regolith, which is essentially loose, unconsolidated, rocky material that you find on the surface of the moon and Mars, and scoop it up, sieve it, and without processing it much more, apply a large amount of heat at a very, very specific heat schedule to basically laze the material onto itself. And so we refer to this as a directed energy deposition process, where we are scooping up the powder material, laying it down, scraping to create a clean datum line, and then sintering it onto itself. Um, and we'll keep doing that in successive layers. You can think of it kind of like a layer cake. We have one material that's 3D printed or lased, and then another layer, and then another layer, successively moving upwards. So far, we've been able to prototype small material samples and specimens that are being structurally tested, and eventually, we want to use specimens of that size to create small tiles for landing pads. And so those will all be fabricated on the surface of the moon,
Wow.
hopefully in the next couple of years.
Again, the future is here. It's here right now. Okay, so I'm trying to think that this really ties in with your project at JSC, right?
Mm,
With the Mars Dune, right?
right.
And this is what I've seen videos of. I hate to jump into our, stepping into our red regolith, jumping to the moon, but I feel like this is a really good transition since we're talking about 3D printing things. Tell us a little bit about that. And I've been fortunate to see slides and videos, but our audience hasn't. So I know this could be a little challenging, but try to draw us a picture if you could.
Yeah, definitely. So while Project Olympus is focused on lunar construction and using the regolith that's local and indigenous to the moon to create different types of structures, the Mars Dune Alpha project, which is otherwise known as the Crew Health and Performance Exploration Analog, is a project that's all about Mars and using 3D printing to essentially construct an analog habitat, which is a simulated Mars habitat here on Earth rather than in space.
Right.
Um, the reason why NASA is so interested in these analog programs and in these experiments is it's the best way to simulate a long duration Mars mission with a crew today to solve many, or I guess we could say address many research gaps that we don't know about what it's going to be like on these future long duration missions. So NASA put out a request for information of former contestants in the 3D printed habitat challenge. I was one of those contestants and winners. When we received the RFI, we submitted to the request, and we were awarded the project. And they basically asked us, "Can you demonstrate that you can 3D print this research facility in about 9 months?" And so that's what we
Wow.
did. Over the course of 6 months, we designed the project in collaboration with the Bjarke Ingels Group and also NASA's Human Habitability Division. And it took us about 4 weeks to 3D print the wall system of the habitat. So that's pretty fast
Yeah.
compared with traditional construction. And outfitting of the habitat, which is basically putting in all of the equipment and the furniture, was done by NASA. And the analog and the experiment for mission one of Chapia is actually operational right now. There are 4 crew members who are inside of that habitat simulating a 1 year long mission. And this first mission will conclude in the summer, I believe sometime in June, if not in July. So really excited to see how that first mission went. It's the longest analog mission that NASA has ever completed. So it's been really exciting to be part of something so historic on the research front.
Yeah, that's amazing. Amazing. Okay, so I know you love tiny robots. I think I read that somewhere. But you are also doing a lot of work with robotic arm technology. Stop me if I get any of this incorrect. And,
Yeah.
some people listening might be like, robotic arms, what's the big deal? Well, audience, I can say for building and living in space, this is a really big deal. Can you just talk to us a couple minutes about this robotic arm work that you're doing?
Yeah, yeah, of course. So, the idea of 3D printing in space is largely focused around building with robots and robots of different sizes and form factors. We've, I guess we could say, tried and tested a couple of different form factors for 3D printing robots. One of them that we use when we're 3D printing buildings here on Earth with our
Mhm.
cementitious material is a gantry based robot. So that's 2 towers with an X beam that goes across them, and it basically prints on rails by rolling back and forth on those rails.
So, like an H shape? Is it
Yeah,
like an H
yeah.
shape? Okay, okay.
So there's constraints with that system. It can only print up to a certain height that it can reach, up to a certain width that it already is based off of where the rails are, and there's some limits to that. And so there's not really a robot arm in that system. It's more of just the print head moving back and forth, right?
Uh-huh.
Um, so because there are limitations to that system, we've actually developed a few new systems, in particular the Phoenix printer, which is essentially a massive robot arm that can print up to 27 feet high.
Oh my
Uh,
gosh. What? Wait, what?
Massive.
Repeat that. 27 feet high?
27 feet high, and it's a massive robot arm that prints in concrete, just like our other printer. There's a concrete hose that goes from the material handler all the way up to the top of the print head, and we're able to realize structures bigger and more eccentric than we ever have before. So there's huge benefits to using a robotic arm, both for on Earth for the construction that we're doing in the residential market and in commercial stuff too, but also in space. In space, we have to think about what our power and energy resources are going to be, and are we going to be tethered to those power resources?
Right.
And if we're not going to be, how far away can we go from those power resources, and for how long will we be able to be 3D printing without having to go and charge back or hook back, right?
Yeah.
Uh, so there's lots of constraints to think about when it comes to the form factor and general size and dimensions of our 3D printers in space. And what we found is that the robot arm form is enabling so much more in terms of building larger and more freeform geometries. And there's lots more to investigate there, but I'll leave it at that.
That's amazing. Well, I think I was one of the early adopter instructors for 3D printing, like 2012 or something like that. And what a change this technology has made. Oh, wait, I think that's Space Dog. I hear Space Dog. All right, it's time for students. So, a little bit about our show, Melody. Our mission, as you know, is to reach every student everywhere. We want students to get excited about their choices in the space industry, and we want to talk about opportunities for their careers, as we've discussed. So, one thing that makes our podcast a little special is that we allow students to submit questions to our guests prior to our interview. And today we have some really special questions for you. We have questions today from some young pioneers, fifth grade students, led by Aiken Quest teacher Jennifer Cooper at Leander ISD. Go, Leander, and go Quest. So, we have about 3 or 4 questions. Are you ready to dive in?
Let's do it. Yeah.
Woohoo! Okay. The first one is from Pradi. What materials do you use and feel are the most important when designing a habitat on the moon?
Oh, what a great question.
Right?
I would say that, well, the material that we're most interested in is the regolith because it's so plentiful and abundant on the surface of the planet. We know that we will never come in short supply
Right.
of regolith. So, I would say a majority of the construction related activity has been imagined, or at least is envisioned, to use local regolith.
Yeah.
But that's not to say that it's the only material that's important. I think it's going to be just as important for us to consider how to manufacture metals on the surface of the moon and Mars.
Mm.
So many applications for that, introducing pressure vessels, rebar for our structures, which is important for us on the engineering side. And also, I think that to really create a more sustainable approach to how we use materials and resources, we have to be thinking about polymers and using recyclable materials as well, which are easy to process and create new things out of. So,
Ah,
I think many materials are going to be important for our presence on the moon and Mars.
that's a great answer. Oh, and I didn't think about metals, but of course. So, question number 2 is from Oliver K. Is the moon colony self sustaining, or will you have to get resources from Earth? That's also a
What
really
a
good one.
great question. Man, I really At best, we would say that the future moon settlements we will try for them to be as self-sustaining as possible. That is going to guide a lot of our technology development, a lot of the logistics having to do with how we create various kinds of infrastructure on the moon. But I think for the first several decades, when we have boots on the moon again, we will definitely need to rely on Earth for replenishing certain resources, materials, especially if we want, humans to do short-term stays on the moon.
Right.
So much is still going to need to come from Earth and be provided by Earth, ranging from oxygen to water to pharmaceuticals, probably food. Like, it will be a long time before we have fully sustainable and fully reproducible systems to manufacture those things independent of Earth.
Yeah. Yeah. Well, that's very insightful. Yeah. So question number 3 is from Ishanvi. He said, "How will you be able to dispose of waste and manage it once you build this lab and habitat on the surface of the moon?"
Such a great question. So, to the greatest extent possible, we want to incorporate and think about how we can use, for example, bioregenerative processes so that we're actually being smarter and more efficient about our waste products and where they're going. And to the greater extent that we can incorporate a kind of closed loop approach
Right.
to how we create food, create oxygen, manage and maintain and replenish our water, I think that we'll have a better chance at introducing a more sustainable approach to living on the moon for a long time.
Right. So, for those of you who are students listening today, all of these things that have been brought up, again, these are future careers, like
Mhm.
ways to research, ways to work to support space habitation and space exploration. There's so many opportunities. So by the time, if you are a young pioneer, say in 5th grade, 6th grade, by the time you're ready to start job hunting, there will probably be postings for these things. So keep it in mind, students. Thank you, Leander and Quest and Jennifer Cooper, for submitting these questions. I wish we could have, talked about all of them, but thank you in particular for these students who we were able to discuss with today. Okay, so before we begin to wrap things up today, Melody, I'm really sad about that, by the way, because I feel like I could talk to you for about 3 more hours. I want to know what I've forgotten to ask you. What have I not asked you that you would like to tell us before we close up shop?
Oh, yeah. Oh, well, first of all, thank you, Holly. This is such a great discussion, and I appreciate being
Oh
here.
my gosh, thank you.
I think that we covered quite a bit. The one thing that I would say is that, there's an expectation that whomever works in space has a formal aerospace engineering background. And more what I'm finding is that the employment landscape and the landscape of specialties and subject matter expertise that is going to matter in space is just so much broader than that.
Yeah.
It doesn't really matter if you have um, a social science background or a psychology background, an engineering background, math or physics background, or even like a, I guess we could say even an anthropology background or an arts background, for example. All of these professions and disciplines are going to be needed and necessary when we think about our future in space. And it also contributes to a more diverse vision of what a sustainable vision of future human life will be.
Yes, yes,
It
yes.
it just can't happen by one discipline alone, and, I think it's so important for us to remember that these cross-disciplinary conversations are gonna be the most productive and the most useful way for us to innovate and introduce new technologies and new ways of thinking about sustainable life in space. There's so many examples of this. I
Yeah.
don't even know where to start, but I would just stress that no matter what subject matter you're interested in, there's definitely a place for you in space.
I I mean, that's a wrap. Mic drop. We're done, right? Yes, that makes my heart so happy. One thing we always talk about with cities in space is we're trying to support the very truth that living off world, we don't want to just survive. We want to
Mhm.
thrive. And this is what you're talking about is thriving. Well, I've got to say, what a wonderful show today. Thank you so much for being here. And I've learned so much today. And I know our listeners have too. I will be continuing to follow Project Olympus and see what other things you will be writing and leading on in the future. So, audience, if you liked what you heard today, please consider following us on our Cities in Space Facebook page, as well as our Instagram at Steaming for Space. And we'd really love to hear from you. How are you using these podcasts in your classroom? We are currently setting up our fall schedule, so please tell us what you want to hear next. You can go to our website at steam-space.org and hit the Contact Us button. If you'd like to support us with a donation, as we seek to reach students everywhere, just visit our site again and hit Support Us. Every donation matters, and it helps us to produce new content and create aligned, essential questions and classroom projects. You can find us on most major podcast platforms such as Spotify, Apple, Google, Amazon. So, our next show will have not one, but two guests. You are going to love this. The Polaris Dawn crew members, Sarah Gellis and Anna Minim, will be discussing the Polaris program and how commercial and governmental collaborations for space are launching us into our new age. Keep a lookout for upcoming essential questions and projects to go with this episode. Special thanks to RNCN for helping produce this podcast, our STEAMSPACE team, to Nate Zivin Productions for our awesome music, and to listeners like you. Until next time, I'm Holly Malier. Keep looking up.